Organized counting with Venn diagrams. The principle of inclusion and exclusion for two sets, which brings us to the concept of common elements and the formula that's involved with two sets. So in the example here, we have 10 students on a volleyball team and 15 on a basketball team. So we have volleyball and basketball. We have 10 on the volleyball team and we have 15 on the basketball team. When planning a field trip for both teams, the coach has to arrange transportation for a total of 19 students. So our universal set is not 25, our universal set is 19. Universal set is denoted by S. So how do we figure out how many students then play on both teams, or the overlap? Well, we take the two numbers added together, so 10 plus 15, and we subtract out the total students, which is 19, and that will give us 6. So we now know that we have 6 students that play on both teams. Well, at this point now we have way too many on the volleyball team. We now have 16 on the volleyball team, and we know there's only 10. So to make that rectify, we take our 10 and subtract out the 6, and we're left with then 4 students that only play on the volleyball team. And now in my blue circle, I have 10 students, which is the number on the volleyball team. The same can now be true for the basketball. We take our 15 and subtract out the 6, and we are left with 9. So now we have the proper number of students. In our basketball circle, there are 15 students in the basketball team. 6 plus 9 is indeed 15. So the formula then below works like this. The number in A or B is 19, and that number equals the number in A itself, so 10 people on the volleyball team, plus the number in B itself, if it were separated out, subtracting the number that is in both. And now you have 19 on both sides of the equation. Looking at the nomenclature, there's a couple different ways to illustrate what we just did. We could use words. So in this case, for sets A and B, the total number of elements in either A or B is the number in A plus the number in B minus the number in both A and B. So those are the words. So in either A or B is the number. Either A or B, either A or B is the number in A plus the number in B minus the number in both A and B. So both A and B. We can also use symbols instead. So in the bottom half of your screen, instead of using words, we're going to use symbols. So we have the union symbol, which is conveniently a U, and the intersection symbol, which is an upside down U. So same thing, one is written with words and one is written with symbols. The next example is about a drama club that is putting on 2 one-act plays. There are 11 actors in the Feydeau farce, and there are 7 in the Molière piece. 3 actors are in both plays. So at this point, we have too many actors in our Venn diagram. In the blue circle on the left, there needs to be a total of only 11, and in the green circle on the right, there should be a total of only 7. So once we subtract out the 3 that are in both, we'll be left with 8 that are only doing the fais-do play, and we'll be left with 4 that are only doing Molière. Our universal set, therefore, 8 plus 3 plus 4 is 15. And the math of that is the total equals the number in set A, which is 15, the fais-do, plus the number in Molière, which is 7, subtracting out the number that are doing both. So 15 does indeed equal 18 minus 3. And now an example with 3 sets. I have one typo to correct before I start. That 12 should be a 52. So of the 140 grade 12 students at Vennville High School, 52 have signed up for biology. We then have 71 signed up for chemistry and 40 for physics. Further, the science students include 15 who are taking both biology and chemistry. We have 8 that are taking chemistry and physics, and 11 who are taking biology and physics. And then we have 2 students who are taking all 3. We have overlapping students, and at this point in each one of our bigger circles for biology, chemistry, and physics, we have too many students in them. So to fix this, we start from the center. So if you look at my red oval, that red oval should only have 15 students in it. So to make that better, you take the 15 and subtract out the 2, and you'll be left with 13 students in the outer part of the oval. Do the same thing for the other 2 sections, so 8 becomes 6, and 11 becomes 9. Now each one of those ovals, whether it be red or blue or green, now has the correct number of students in it. There are 8, for example, in the green oval, and we have 8 students taking both chemistry and physics, so the overlap has now been corrected. What we haven't accounted for is the overlap for the bigger circles. So now if we look at a big red circle that should only have 50 students in it, we have way too many. The same thing then with the green. It's going to get conflicting here with the colors, and the same thing then with the blue. So we need to rectify the bigger circles for biology, chemistry, and physics. And to do this, we take, for example, in biology, take the 52 and subtract out the 13, the 2, and the 9. So 13 plus 2 plus 9 taken away from 52 would leave us with 28 in the biology larger circle. And in chemistry, once you take away the other values, you're left with 50. And in physics, you're left with 23. So now you're going to have a situation where if you correct the 3 circles, you've got 28, 13, 2, and 9. And in that circle for biology, you've only got 52 students. So you can do the same thing for the other circles. So now you've got 50 that are simply taking physics. And if you add the 6 in, you now have accounted for the other students. So you have a total of 71. When you add up all the numbers in the green circle, you have 71 students taking chemistry. And just to finish off, if you put the 23 in where physics goes. In our blue circle, we will have 40 students, 23 plus 9 plus 2 plus 6. So mathematically, you can also figure this out using the formula. So 52 plus the 71 plus the 40. Subtract out the 3 overlapping and add back in the center, which is in each of the 3 sets. You'll get a grand total, or a universal set, of 131. Okay? Now the universal set is 131, but if we were told that there are 140 grade 12 students, that universal set actually no longer adds up. So there should be an additional 9 students that are not taking anything. So to account for the universal set, not of 131, of 140, you would have to place a 9 outside of the 3 rings. So here's the formula, again with the intersections and the unions. And in both cases, the total of 131 is equal to 52 in A plus 71 in B plus 40 in C. Subtract out A and B, B and C, A and C, and add back in A and B and C. And whether you're using words or symbols, both sides will balance to 131. Thanks for listening.